This video is going to illustrate how to find the equation of a line through 2 points. And the 2 points that we're going to use are 4 and -3 and -1 and 5. Now for every equation of a line, we need to find the slope. Now there's an equation for slope. That equation is m equals y2 minus y1 over x2 minus x1. Now we have these 2 points. We need to designate this as x1 or x2 and this as x1 or y1 or y2. Now it doesn't matter which point is which. Because this one's first, and that's the only reason, I'm going to simply designate this as x1 and y1 and this point as x2 and y2. Had we switched that, we would still get the exact same answer. So we now substitute these values in. Y2 is 5. We're going to subtract -3. Because we're subtracting a negative, I'm going to use parentheses for some structure. And we're going to divide this by x2, which is -1, minus 4. Now we're going to simplify this using a little arithmetic. So we have 5 minus a -3, which is 5 plus 3, over -4 minus 1. So this will be simplified to 8 over. Now this is -5. We can put that negative out in front as well as leaving it in the denominator. Both of those will be equivalent. So this represents our slope. Now that we have the slope, there are 2 methods in general that we can use to find the equation of the line. The first we're going to do today is using the point-slope form. And based upon this title, of course, we want to find the point and a slope. Well, we just found the slope, and we have 2 points. Since we've already designated this as x1 and y1, let's use those to simplify this equation into the equation we want that runs through these 2 points. So we'll have y minus, again, -3, again, structure. We'll have our -8/5 for our slope. And then x minus, and here x1 is 4. And now we're going to do our simplification. So we have y plus 3. Here we have a constant times a quantity in this set of parentheses. So we'll use the distributive property and multiply this constant by both of these values. So we'll have -8/5 times x, which is -8 over 5x. And then when we multiply a fraction by a constant, typically, if that constant is an integer, we place it over 1. Because when we multiply fractions, we multiply the numerators, and then we multiply the denominators. So here we have negative times a negative, which will give us a positive, 8 times 4, which will give us 32, and 5 times 1, which will give us 5. Now from here, we like to have y equals. So we would need to remove this 3 from the left-hand side. In order to do that, we want to use the inverse operation of addition. So we want to subtract 3 from both sides. Now 3 on this side, because we have this denominator of 5, when we add and subtract fractions, we need a common denominator. So 3 is equivalent, with 5 as the denominator, of 15 over 5. So notice 3 is equivalent to -15 over 5. And the reason we're doing this is because when we subtract or add fractions, we need a common denominator. So here we have 0. 0 plus y would be y. On the right-hand side, we have the -8/5 because these terms are not like. Here we have 2 fractions. We combine the numerators. 32 minus 15 is 17. And our denominator is still 5. And this is the equation of the line through 2 points. We could stop here if we wanted to. For illustration purposes, I'm also going to show you the second method that I mentioned. If we use the equation y equals mx plus b. Now this is the slope-intercept form of a line. because we have the slope and we have the y-intercept. Had either of these had an x value of 0, then we simply would have already had the y-intercept. But since we don't have the y-intercept, we have to find it if we're going to use this equation. So, to show you that it doesn't matter which coordinate we use, I'm going to use the second coordinate for this second method and show you that at the end we'll have the exact same result. So here we have y of 5. Our slope is negative 8/5 as we found earlier. Our x is negative 1. And then, as I mentioned, we're looking for b. We have 5 here. When we multiply fractions, as we mentioned in this example, we multiply the numerators and we multiply the denominators. So here we have positive, because we have two negatives being multiplied together, 8/5. And now to find b, we need to subtract this 8/5 from both sides. So this reduces to 0, and we'll have b equals 5 minus 8/5. And again, our next step is to subtract these two values. And when we subtract fractions, again, we need this common denominator. So our common denominator here would be 5. In order to get this 5, we needed to multiply this 1 by 5. And again, this is just a small review. So here's 5 times 5, which give me 25. Again, notice it's equivalent to 5. Here we have our 8/5 and we have our b. So now, when we look at these two fractions and combine them, we have 25 minus 8, which is 17. And b is 17/5, as we had found when it was in y equals mx plus b form. So if we found this b, and we initially had stated that our slope was negative 8/5, we have now shown that with these two values, we have the exact same result using either method.